Here, I merely have a polynomial function. So let's you and I clearly sketch this graph and clearly label all intercepts, as well as inflection points and local extrema. Now, if you don't mind, I've taken care of the work of differentiating twice, building sign graphs for all three of these, y, y prime, and y double prime. Let's see if you and I can't put this all together. Now, notice how the sign graph for y tells me when I live above and below the x-axis. The sign graph for y prime tells me where the original function changed from decreasing to increasing and vice versa. And finally, the second derivative sign graph tells me something about concavity. Concave up, concave down, concave up. Let's see if you and I can put this all together. I have x-intercepts here, here, and here. I live above, there, below, here and here, but I pass this x-intercept, probably do something like that. Roughly speaking, I'm being very sloppy. But I changed from concave down to concave up about an x value given right here. So let me now try to take that W shape and put a bit of curvature to it. So to the left of this x-intercept, my y values are positive, but I'm decreasing. As I pass through that x-intercept, my y values become negative. But I continue to be decreasing up to an x value of -1/√2. I'll leave it for you to find the y values. Now, I become increasing after that x value, but change from increasing to decreasing when I hit that x-intercept. All the meanwhile, I'm negative. And so after decreasing, I'll increase about that value of x. That's 1/√2. And then continue to increase. Now notice about roughly here and here, I changed concavity. And this sign graph for the second derivative function does indeed say that I changed from being concave up to concave down at a point whose x-coordinate is this. Again, I'll leave it for you to find the y value. But then I changed from concave down to concave up about an x value described here. Looks like I've got some kind of symmetry with this pretty picture. Well, I didn't draw very well, but there is symmetry with respect to the y-axis, but you knew that. Because you know just at a glance that that's definitely an even function. Even functions have symmetry with respect to the y-axis, albeit I didn't do a very good job showing that symmetry.